Hello and welcome back to the course. Super excited to have you on board. Today we've got a very interesting and important tutorial, assumptions of linear regression. So let's have a look. Here we've got a dataset with a linear regression applied, and this linear regression seems to be serving its purpose really well. However, if we look at the following three datasets, we can see that a linear regression is applied each time. And in fact, it's exactly the same linear regression as in the first case. However, those linear regressions are not serving their purpose. In fact, they are misleading. So we shouldn't be using linear regressions in those situations. These four datasets are called the Anscombe's quartet, and they illustrate that you can't just simply blindly apply a linear regression. You have to make sure that your dataset is fit for using linear regression. And that's where assumptions of linear regression come in. So let's have a look at them. There's going to be 5 assumptions in total, plus an extra check. The first assumption is linearity. We want to make sure that there is a linear relationship between our dependent variable and each independent variable. And if you look at the chart here on the right, you'll see that the linear regression is misleading. There is actually no linear relationship between the two variables. So we wouldn't use this kind of model there. The second assumption is homoscedasticity. And even though it sounds like a complex term, it actually simply means equal variance, meaning that you don't want to see a cone type shape on your chart, whether an increasing cone or a decreasing cone, which would mean that variance is dependent on the independent variable. So in this case, we wouldn't use a linear regression either. The third assumption is multivariate normality, or normality of error distribution. If you look at the chart here on the right, you can feel that something is off. The best way to intuitively think about it is if you look along the line of the linear regression, you want to see a normal distribution of your data points. In the case on the right here, we can see something different. And so again, we wouldn't apply a linear regression there. The fourth assumption is independence of observations, and this includes the term no autocorrelation. Sometimes you'll see this assumption titled as no autocorrelation. And what that means is that we don't want to see any kind of pattern in our data. A pattern in the data like we see here indicates that our rows are not independent, that some rows are affecting other rows and other rows, etc. A classic example of this would be the stock market, where previous prices affect future prices, which affect future prices, and so on. So in this case, we wouldn't apply a linear regression model. The fifth assumption is lack of multicollinearity. Basically, we want our independent variables or predictors not to be correlated with each other. If they're not correlated, then we can build a linear regression. If they are correlated, then if we do proceed and build a linear regression model, then the coefficient estimates that we get in the model will become unreliable. And the sixth point is the outlier check. This is not an actual assumption, but rather an extra check that is important to keep in mind when building linear regression models. If you look at the chart here on the right, you can see that the outlier is significantly affecting the linear regression line that we get. So something that we want to consider is, should we remove the outliers before building a linear regression, or do we want to build a linear regression with the outliers included? This will depend on your business knowledge and knowledge of the dataset. So there we go. Those are the assumptions of linear regression. In this course, we're going to assume by default that they are correct for all the datasets that we work with. However, when you're working with your own datasets, it's important to do these checks to make sure you're building a linear regression when it is fit for the dataset. And to finish off this tutorial, I have a special bonus for you. If you enjoyed this explanation, you can download the PDF version of this slide and keep it at home, print it out as a poster, keep it somewhere handy for those times when you do need to check assumptions of linear regression. If that's something that you would like to have, head on over to superdatascience.com/assumptions and you can download your poster there. And I look forward to seeing you back here next time. Until then, enjoy machine learning.